To all. Today I am going to explain the electromagnetic waves chapter. In this, what I am going to explain first. First, what is electromagnetic wave? Electromagnetic wave is also wave. After invention of the electromagnetic wave, right, the wireless communication started, and television communication, radio communication, and mobile communication occurred because of electromagnetic wave. What is actually electromagnetic wave, and what is the source of electromagnetic wave, and what are the uses of the electromagnetic wave? That all things we are going to discuss. First of all, electromagnetic wave means it is a wave. In this, its name only there that it is electromagnetic wave, means it has electric and magnetic fields. This wave has electric and magnetic fields that are oscillating electric and magnetic fields. This wave has the wave which have oscillating electric and magnetic fields which are perpendicular to each other and also perpendicular to the direction of propagation of wave. Let us see its diagram, how the wave diagram will be there. This is the wave diagram. In this, the wave is traveling along, the electromagnetic wave is traveling along x-axis. You see here, this is the x-axis. Electromagnetic wave is traveling along x-axis, but the electric field is along the y-axis. Electric field is oscillating along the y-axis and magnetic field is oscillating along the z-axis. You see here these lines. This indicates the magnetic field along the z-axis. This is electric field that is along the y-axis. That means when the electromagnetic moves along the x-axis, then it has oscillating electric field that is along the y-axis and oscillating magnetic field along the z-axis. Electric field along the y-axis, magnetic field along the z-axis, and electromagnetic wave is traveling along the x-axis. That means this electromagnetic wave has oscillating electric and magnetic fields which are perpendicular to each other and also perpendicular to the direction of propagation of wave. Let us see sources of EM wave. In that first point I gave that accelerated charges radiate the energy in the form of EM wave. Who is producing the EM wave? Who is the source of EM wave? That is, accelerated charges are the source of EM wave. Accelerated charges means what? They should not have zero acceleration. If the velocity of charge increases, if the velocity of charge decreases, that is said to be accelerating charge. If the charge value is changing with the time, if the charge value is increasing and decreasing, charge magnitude is, that is oscillating charge. An oscillating charge produces, second point I am going to read, an oscillating charge can produce the oscillating electric field. We know that the charge can produce the electric field. If the varying charge is there, oscillating charge is there, then it can produce the oscillating electric field. That oscillating electric field can produce the oscillating magnetic field. That means electric field can produce the magnetic field, and magnetic field also again produces the electric field. They can regenerate with each other, and due to that, the electromagnetic wave will be travel in forward direction. The oscillating electric field can produce in the space, that can produce the magnetic field, and that magnetic field again produce the electric field. Like this, electric field after magnetic field after electric field, like that in the space it can travel. And fourth point I am going to give, an electric charge oscillating harmonically with certain frequency produces the EM wave with the same frequency. With how much frequency the charge is oscillating, with that much frequency EM wave is producing. EM wave means electromagnetic wave. We already know that the electromagnetic wave is produced in the LC circuit. Nature of EM wave. What is the nature of EM wave? How it will be there? And already we discussed in the, when we looked at electromagnetic wave. Here, this is the diagram of electromagnetic wave. Electromagnetic wave has oscillating electric and magnetic fields which are mutually perpendicular to each other and also perpendicular to the direction of propagation of wave. That is the definition. And electromagnetic wave direction. For example, electric field is along the y-axis. We know that one electric field is along the y-axis and magnetic field is along the z-axis in this figure. Okay, and electric field is along the y-axis means we know that I cap, j cap, k cap. What are they? This I cap, j cap, k cap are the unit vectors along the x-axis and y-axis and z-axis, right? I cap indicates the x-axis, j cap is the y-axis, k cap is the z-axis. If you want the direction of EM wave in which direction it is going, if electric field is along the y-axis, that is a j cap, magnetic field is along the z-axis, that means k cap. Then what about the direction of motion of EM wave? The electric field direction we know, the magnetic field direction we know, but I want the motion of EM wave direction. Then that is given by the E bar cross B bar. That is EM wave travel along a direction, that is E bar cross B bar. What is the E direction in the figure? J. What is the B direction in the figure? K. And then we wrote here J cap cross K cap, Y and Z axis. When J cap cross K cap we know already, that is equal to I cap. That means electromagnetic wave can travel along the positive x axis. Let us see that if EM wave is traveling along the positive x axis and then electric field is oscillating parallel to the y axis and the magnetic field is oscillating parallel to the z axis, that we know already, and then at the moment electric field and magnetic field sinusoidal function of position and time. Okay, look at here. If we go for the electric field, if we draw the diagram here, and electric field we wrote along the y-axis, this is the electric field is taken on y-axis, and the time is taken on x-axis. If we draw the graph, we will get like this. That is sinusoidally we will get. Already we saw the diagram in the previously. That is electric field value is varying with the time at any location. If you want at any location, if you want the at any location, if you want the electric field value, then how we will get? If you want the electric field direction at any point, then we can get very easily like this. That is, for example, this is the location. After some time, this is the distance from here to here. It travels some, or otherwise you take this point, and from here, and the distance we can take as x, and after time t, here this is the location. At this location, electric field value, some value is there. The electric field value is increasing, next decreasing, and increasing opposite directionally, and next decreasing sinusoidally. Electric field is changing it here. Then at any location, electric field can be written as, that is E suffix y. Electric field is along the y-axis, that is equal to E naught sine kx minus omega t, and the magnetic field is oscillating along the z-axis. It can be written as Bz is equal to magnetic field along z-axis, Bz equal to B naught sine kx minus omega t. Electric field and magnetic field both are changes with the time and position. These are the sinusoidally oscillating electric and magnetic fields. That's why we wrote in sine functions. Okay, where E naught and B naught, in this we know that E naught and B naught, these are the peak value of electric field and peak value of magnetic field. Okay, x is the position, at what distance electric field we are getting, after what time we are getting. Okay, some more terms I will explain in this equation. What is k? K is the propagation constant. Its formula is, or wave number, its formula is k is equal to 2 pi by lambda, and omega is the angular frequency in this term. There is a omega is also there. That omega is the angular frequency. Its formula is 2 pi nu. Okay, and there is a one formula is there for the speed of EM wave in the vacuum. Speed of EM wave in the vacuum. Speed of EM wave is c, that is equal to speed of light. Its formula is omega by k. You know here omega is 2 pi nu, k is 2 pi by lambda. If you substitute omega and k here, we will get nu lambda. And one more formula is E naught by B naught, peak value of electric field by peak value of magnetic field, or otherwise ERMS by BRMS. Next, I am going to explain one more formula for the speed of EM wave. Then what is that formula? You see here the cursor, how it is going on. Speed of EM wave, one more formula in free space or vacuum, that is 1 by root nu naught epsilon naught. This is the formula. Here mu naught value we know already, permeability of free space, that is a 4.2 to the power of -7 Henry per meter. Epsilon naught is the permittivity of free space, that is we know already 8.85 to the power of -12 Farad per meter. And these two, if you substitute, you will get 3 into 10 to the power of 8 meter per second. That means EM wave travel with the speed of light in vacuum, and the speed of EM wave in the medium. This is the formula for the in the vacuum, speed of light in vacuum. But speed of light in medium we have to write like this. That is, speed of light in vacuum is C. Speed of light in medium is V. Its formula is 1 by root nu epsilon we write. Nu is the permeability of medium and mu epsilon is the permittivity of medium. We know formula for mu, that is the, we know the mu formula. Mu formula is mu r into mu naught, and epsilon formula is, you know, epsilon r into epsilon naught. This we can change like this. That is, first we write the mu naught. This one we can write like this. This equation we can write like this. That is, this mu naught and epsilon naught one side we write. That is, we will get 1 by root nu naught epsilon naught we will get. But 1 by root nu naught epsilon naught is, we know, C. Then by that we will get this nu naught epsilon naught we will get as C, 1 by root nu naught epsilon naught, by remaining is under root nu r epsilon r. That means the speed of light in medium is equal to speed of light in vacuum by under root nu r epsilon r. And the refractive index of the medium next. If you know the mu r and epsilon r, we can find out the refractive index also. The refractive index formula, we know that the C by V is the formula for the refractive index. That is the speed of light in vacuum by speed of light in medium. That is, here we know from this formula, V is equal to, we know this one, V is equal to, we know, C by under root nu r epsilon r. From that, if you write the C by V formula, we will get under root nu r, this is the root, under root nu r epsilon r. Okay, this is the formula for the refractive index of certain medium. And now next I am going to explain the properties of EM wave. And first property is that it has transverse nature. That is, you know that the light has transverse nature. Similarly, EM wave has transverse nature. It does not deflected in second point is that it does not deflected in electric and magnetic fields. If we pass the EM wave in the electric field or the magnetic field, it is does not deflected, means it is neutrally charged. And the next, EM wave travel with the same speed of light, same speed in vacuum with the speed of light. EM wave travel with the same speed in vacuum. All the EM waves travel with the same speed, that is equal to speed of light. Fourth point is that no material medium required for its propagation. EM in vacuum also it can travel, that means medium is not required. They get refracted, diffracted and polarized. They have oscillating electric and magnetic fields which are mutually perpendicular to each other and also perpendicular to the direction of propagation of wave. This we know already. And the seventh point, let us see here. Electromagnetic wave can transfer energy as well as momentum to the objects placed on their path. That means if electromagnetic wave incident on any surface, on any object, it can transfer certain momentum. It can transfer certain momentum means it can apply the force on the objects. It can apply the pressure on the objects which are present in the path of EM wave. Let us see next slide. That is electromagnetic spectrum. Electromagnetic spectrum. What is an electromagnetic spectrum? There are several types of electromagnetic waves are there, right? Then they can arrange it in according to their wavelengths. The arrangement of the electromagnetic waves according to their wavelengths is called as electromagnetic spectrum. Here we are arranging the electromagnetic waves. This is the gamma ray, and next X-ray, and next UV ray, next visible rays, IR rays, and microwaves and radio waves. These are all electromagnetic waves. They are arranged according to their wavelengths. That means from gamma rays to radio waves, wavelength is increasing. Here we wrote lambda is increasing when you go to right side. That means the highest wavelength is there for the radio waves, highest wavelength, and the lowest wavelength is for the gamma rays. Okay, wavelength lambda is minimum for the gamma rays, and radio waves have the maximum wavelength, and the frequency, when the wavelength is increases, the frequency is decreases. That means highest frequency for the radio waves, lowest frequency for gamma rays. And next, there is one code is there to remember these waves in certain order, right? That is gx uv imr. G means gamma rays, x means x-rays, u means ultraviolet rays, v means visible, I means infrared, m means micro, r means radio waves. This, if in this order if you will go, the wavelength is increases and frequency is decreases, because frequency and wavelengths are inversely proportional to each other. Let's go for the next slide. That is, first there are, I said that there are there are seven types of EM waves are there, and each EM wave how it can be produced, and what are their uses, that we are going to discuss now. Okay, now let us see here. First, gamma rays. What are the gamma rays? And the gamma rays main source is what? The main source of gamma rays is natural and artificial radioactive substances. The uses of the gamma rays. First point, let us see. First use, gamma rays are used in the medicine to destroy the cancer cells. Second, gamma rays are used in nuclear reaction because of their high penetrating power. Okay, gamma rays are used in the nuclear reaction. And the next one is, the third use is that the gamma rays are affect the photographic plate. You know that photographic plate, right? That can be affected by the gamma rays. Next, X-rays. X-rays are produced in X-ray tube when high energy electrons bombard on a metal plate like molybdenum or anything. And if high energy electrons bombard on the metal plate, then X-rays are generated. These X-rays generally damage or destroy the living tissue and organism, and care must be taken to avoid the unnecessary overexposure. We have to take care of X-rays. We should not go for the unnecessary exposure of these X-rays. And now let us go for the uses of this X-rays. Let us see, there are several uses. Here heading is missing, and the first use is that these are mainly used in detecting the fractures of bones, tuberculosis of lungs, and presence of stones in gallbladder and kidney. Hidden bullets are the needles. These all can be find out by using X-ray. We know already that one. X-ray is also used to study the crystal structure. These are also used to study the crystal structure. And X-rays are used in the engineering to detect the flaws in bridges. If there is any flaws, problems, mistakes, is there any gaps, is there any cracks in the bridges, that inside the bridges, and that can be find out by using X-rays. And then X-rays can also use it to cure the cancer. Next, we will discuss about the third type of electromagnetic waves, that is ultraviolet rays. These rays are produced by special lamps and very hot bodies. Sun is the important source of UV rays. Okay, UV rays are generated by using special lamps and very hot bodies. This sun is the main source of the UV rays. Let us go for the uses. And due to short wavelength, these are used in LASIK eye surgery. LASIK eye surgery. LASIK is the name of eye surgery, and that is LASIK full form is the laser assisted in situ keratomelysis. Second use of ultraviolet rays is that UV lamps are UV rays used to kill the germs in water purifier. We will use in the ultraviolet rays in the water purifier to kill the germs. And the third use is that they are used to sterilize the surgical instruments, to clean the surgical instruments. And these rays are used to detect the invisible writing and fogged documents. Okay, and in the documents there is something is written, but that is not appeared. That can be detected by using this UV rays. And fingerprints in the forensic lab. Okay, and also use it to preserve the foods. Next, fifth point we will read. That is, a UV rays can cause the photoelectric effect that are used in the burglar alarms. Next, welder can wear a special glass goggles to protect the eyes from UV rays. Let us go for the next type of rays, that is the fourth one, that is a visible light. And these are part of electromagnetic spectrum. These are part of electromagnetic spectrum detected by human eye. These are used to see the objects. We can see whatever that around us due to this visible light. Next, let us go for the fifth point, infrared rays. All hot bodies are the sources of infrared radiations. IR radiations means heat radiations. Okay, and the use is that let us study the uses of these IR radiations. IR rays are used in the taking the photographs during the fog and smoke. IR rays are used to treat the muscular strains. That means in physiotherapy they will use the IR radiations. And the next third point is that IR radiations are widely used in the remote switches. This is important point. In the household electronic system like television and AC, we will use the remote to change the channels, and that are our remote can generate the IR radiations, and that can gives the instructions for certain function. IR radiations are also used to forecast the weather changes. And next, fifth point, fifth use of IR radiations are IR detectors used in Earth satellite, both military purpose and also observe the growth of crops. Next, sixth point, IR rays are used to provide the electrical energy to satellite by using solar cell. IR rays also produces the electrical energy for the satellites by using solar cell. This IR rays are incident on the solar cell. Solar cell absorbs the that IR energy, heat energy, and that will convert into electrical energy. And the seventh point I am going to explain, that is IR rays are used in the solar water heaters and the solar cookers and solar water heaters. In that, heat should require that heat is generated absorbed from IR rays. And the next eighth point is that IR rays from the sun keep the earth warm. Earth can maintain it in warm by using this IR radiations through the greenhouse effect. Next, I am going to explain the sixth type of electromagnetic waves, that is the microwaves. These microwaves are produced by special vacuum tubes. They are called as klystrons, magnetrons, and gun diodes. These are the shorter wavelength radio waves. The uses of the microwaves are used in radar system. The first point, microwaves are used in radar. Radar means radio detection and ranging. They are used to find out the depth of ocean and some objects we can find out. And this system is useful in the aircraft navigation. Okay, for their short wavelength, because of their short wavelength. These microwaves are the short wavelengths of radio waves. In the radio waves, short wavelengths are called as radio waves with short wavelengths. Less wavelengths are called as the microwaves. These microwaves are used in radar system because of their short wavelengths. Based on the microwave, second point we are going to discuss this. Based on the microwaves, the speed guns can be found out. That speed guns are used to find out the speed of fast moving. This is fast speed of fast moving. It's not fat, it is a fast moving balls. Okay, we know that in the bowling, how much speed the bowler is bowling, that speed can find out. Our automobile speed can be find out by using the speed guns. In that, the microwaves are used. Third point is that the microwaves are used in microwave ovens to cook the food. That is a domestic application. Let us discuss about the principle of microwave oven. What is the principle of the microwave oven? In the microwave oven, we will use some food item like egg puff or curry puff. It contains the water molecules. Okay, the frequency of, they will send some microwave into that. If the frequency of microwave equal to the frequency of water molecules which are present in the food item, at that moment the total energy of EM wave can be transferred effectively to the kinetic energy of molecules. That means that water molecules can absorb, water molecules which are present in EM wave, the water molecules which are present in the microwave oven, they absorb the energy of microwave. Okay, when they will absorb the energy of electromagnetic wave microwave, if the frequency of water molecules is equal to the frequency of microwave, then the microwave energy is absorbed by the water molecules which are present in food item. They can vibrate with more kinetic energy, and due to that their temperature will increases. With that, food item will be cooked. Next type is radio waves we are going to discuss. That is, the radio waves is the last type of electromagnetic wave, and radio waves are used produced by accelerated motion of charges. Okay, in LC circuit we will generate. These are used in the radio, TV, cell phone communication. Okay, next radio frequency range they gave 88 megahertz to 108 megahertz and 54 to 890 for the TV brand frequency range, and cellular frequency range is this one 300 to 3000 megahertz. That means radio waves are used in the wireless communication, television communication, cell phone communication, radio communication. We are using the radio waves. Now in the last but one, we are going to discuss in this the frequency range and wavelength range of electromagnetic waves. That is, electromagnetic waves are the waves which are seven types. There is a gamma rays, X-rays, UV rays, visible rays, and infrared rays, microwaves, radio waves. These are all we discussed. All the electromagnetic waves, how they will generate, and what are the uses of them, that we discussed. And now in this table I gave the frequency range and wavelength range of electromagnetic waves, and you have to note the frequency range. And by this frequency range, in the exam they may ask what is the electromagnetic wave which have this frequency range, then what is the name of that electromagnetic wave. That's well, it is important to remember the frequency range and wavelength range of EM waves. Okay, thank you to all. Subscribe and share my channel.